Hello everyone. Today's video is going to be on equation word problems. So the cool thing about the word problems is, they are like real life applicable. As you can see in some of these situations, these are some situations that could happen to you in real life at some point. If you look at numbers 1 and 2, number 1 has to do with air conditioning repair, which you guys might have to worry about eventually. And number 2 is definitely something that could apply to you right now as an 8th grader. You're going bowling, but we will get to that in a second. So the biggest thing with word problems is from the start you need to define what your variable means. So if you read number 1, we're trying to find how many hours were worked. So your answer is going to be however many hours you worked. So let's define from the start that x equals hours. You could use any variable, but I'm just going to use x. So the first thing we need to do is we need to make an equation. So the total bill was $500. So we know that we're going to be equaling $500 because that was the total bill. And then Ralph's Repair Service charged $250 for parts and $50 per hour for labor. So you need to think to yourself, okay, what number is going to go with my variable? Well, the thing that changes is how many hours. So we're going to need 50 with the x, 50x, because it's $50 per hour and we don't know how many hours yet. And then it's going to be plus 250 because that's just like a flat rate. That's how much it costs for the parts. There's no variable that goes with the parts. That's just how much they cost. So once we set up our equation, I am confident in your guys' ability to solve this. But just to do it pretty quickly, solving that multi-step equation for x. So x is going to equal 5. So your answer is 5 hours. And again, if you wanted to check, you would plug that 5 back in for x, and you should get 500 equals 500 on both sides. So the next problem, again, we need to define what our variable is. So if you look, this is kind of a little trick. If you look in the last sentence of these questions, a lot of them will kind of tell you what the variable should be. So what is the maximum number of games that they can bowl? So x is going to be the amount of games. That's what we're trying to find out. So when we set up our equation, we just got to think about, okay, she can spend up to $16. So that's the total. That's what our equation is going to equal. And then it costs $250 a game. So that x we decided was going to be the number of games, so that x needs to go with the $250. And then kind of like the problem above, the bowling shoes, those are some cheap bowling shoes, but those cost $1.50. So that's just kind of a flat rate you're just adding on to the cost. So with these problems, the hard part is kind of just setting up your equation, taking what's in the question and setting up your equation accurately. But once you have your equation, a lot of these are just going to be some two-step equations. So if I solve this, might need some more room here, we'll see. 16 minus $1.50 is $14.50. And then it looks like x is going to equal $5.8. So x equals 5.8. So we have to think about it for a second. Back in the original question it said, what is the maximum number of games that she can bowl? You can't bowl 8/10 of a game. Like, you either bowl a game or you don't. So if we rounded this answer to 6, well, that would actually cost a little bit more than the $16 we have. Right? We can't afford 6 games because that would push us over that $16 amount. So we have to actually round our answer down to 5 games. So Ruth will be able to play 5 games and have a little bit of money left over. All right, we're going to move right along. Number 3 is a little bit more involved just because there's all these different colors we have to account for. So first of all, it says let R equal red. So the next part is blue. So if we look up here at the first line, there are twice as many blues as there are reds. Now, we're not going to have like 4 different variables in this equation. We can only have one variable, and it's R. It tells you right there R is red. So we need to come up with these next 3, blue, green, and yellow. We need to come up with these in terms of R. So what I mean by that is there are twice as many blues as there are reds. So this is kind of like the translating we did on the Unit 1 test. There are twice as many blues as there are reds, so we're going to represent blue with 2R. There are 4 more greens than there are reds, so we're going to represent that with R plus 4. And then finally, there are 6 less yellow than red, so that is going to be R minus 6. So if we write all of these out, we know there are 53 total candies. So that's going to be our equals. And then we have our reds, which are represented by R. Then we have our blues, which is plus 2R, like we have up top. Then we have our greens, which is plus R plus 4. And then we have our yellows, so we have plus R minus 6. So again, kind of the challenging part is just to come up with your equation. It might take a little bit of practice. But once we have our equation, we're just doing our multi-step equation steps. We're distributing if possible. We're combining like terms like I'm doing here. So when you combine all the r's, we have 5r. And when you combine the constants, we have negative 2. So we get 5r equals 55. And finally, R equals 11. So your answer, we need to figure out, we need to write down all the different colors. So red was R, which is just 11. Blue is 2R, so if R is 11, that means blue is 22. Green is R plus 4, so if R is 11, green is going to be 15. And finally, yellow. Yellow is R minus 6, so 11 minus 6 is 5. The fourth problem is a little bit different. We're talking about the length of a rectangle now. So for our solution, we actually have to figure out what is the area of the rectangle. So in order to find the area of a rectangle, we need to find the width and the length. So again, at the start, we need to represent we need to define our variables. So the width, we can just say is W. That makes sense. And then the length, we need to define the length in terms of the width. So it tells us in the first sentence, the length of a rectangle is 6 times the width. So if the width is W, the length is just going to be 6W. Now for my equation, remember this is a rectangle. There are 4 sides. So you need to make sure you account for all 4 sides. You can't just account for 2 of them. And then finally, now that you have your equation, we're just going to solve it. So when we combine all of our like terms, we have 14W equals 56. And then finally, W is going to equal 4. So the width is 4. If the width is 4, that means the length is 6 times 4, which is 24. So I just realized I actually messed this up on the key. The question was asking what is the area of the rectangle. So I had on the key the width and the length, but in order to find the area of a rectangle, you actually have to multiply those 2 together. So your solution is 24 times 4. And 24 times 4 is 96. So my solution is 96 centimeters. Remember, area is squared. So for the last section, perimeter of rectangles, A little bit different than what we just did because I was asking for the area. I'm going to do 2 with you together, and then I'm going to send you on your own to try the last 3. The last 3 are very similar to the first 2 we're going to do. So I want you to take my examples and try them on your own. And then, like I said, the key will be posted for you to check your answers. So we need to define our variables again. I'm going to try to write small because these boxes are a little small on my screen. Anyways, the width is going to be W. The width can be W for all of these. And then we need to define the length in terms of the width. So the length of a rectangle is 6 inches more than its width. So we're going to represent that with W plus 6. Now when we write our equation, again, remember it has 4 sides. It has 2 lengths and 2 widths. So right now I have my 2 lengths represented, and then I need my 2 widths represented. And it tells you the perimeter is 24. So when we combine like terms, we have 4W plus 12 equals 24, and then we're just going to solve this. It looks like I'm going to run out of room. 4W equals 12, and then we just need to divide both sides by 4. So the width is going to be 3 inches, and the length is W plus 6. So if W is 3, 3 plus 6 is 9 inches for the length. Alright, number 2 is very similar, like I said. Define your variables. The width is W, and the length is 5 inches more than 4 times its width. 5 inches more than 4 times its width. So think back to that translating. 4 times its width is 4W, and then 5 inches more than that. So you need to make sure you set up your width and your length correctly. Your length is in terms of the width. And then remember, you just need to account for all 4 sides. So right there on my screen I have both of my lengths, but I don't have my widths yet, which I'm now writing down. So right there I have all 4 sides represented, and it equals 90, and then we're just combining like terms. So 10W plus 10 equals 90. And it looks like I'm going to run out of room again. So we have 10W equals 80. 90 minus 10 is 80. And then last step is just dividing both sides by 10. So W, the width is going to equal 8 inches. And then the length, look back to the start, we define the length as 4W plus 5. So if W is 8, 8 times 4 is 32, and 32 plus 5 is 37 inches. A quick way to check these is just to plug it back in. You could also think to yourself, okay, if I look back to number 1, the perimeter is 24 inches. So the perimeter is just 2 lengths, 9 plus 9, and then 2 widths, plus 3 plus 3. And that should equal 24. 9 plus 9 is 18, plus 3 is 21, plus 3 is 24. So 24 equals 24, that means we are correct. So these are actually pretty easy to check. So if you put in that extra 15, 20 seconds to check it, you can have that peace of mind that you know you are correct. So like I said, there are 3 more problems, and they are similar to the 2 that I just did. So I want you to try these on your own, and then I want you to check your answers on the key that will be posted on Google Classroom.